Hey everybody, thanks for clicking on this video. If you want to follow along, the links to the companion worksheets are in the description below. Now today we're dealing with finding volume when we have disks that are perpendicular to the y-axis. So this is very similar to the previous video we did where disks were perpendicular to the x-axis. Now, like I said before, oftentimes calculus books will call this the disk method, and that's true. But basically, the idea is we're thinking of these as disc-shaped slices. So the first thing we have to do is we first have to draw out the region bounded by what's given. So here it's bounded by y equals square root of x, y equals 0, and x equals 4. Now the thing to keep in mind is you do not get the x and y axis as freebies. Those aren't automatically boundaries. So here's one boundary. Y equals 0 is the x-axis. We get that as a boundary. And then x equals 4 is our other boundary, which is up here at 4, 2. And so it's always good to draw out and label your boundaries so that you can clearly see, all right, what region are we talking about? It's this. Now the next thing is that we're rotating it about x equals 4. So this region borders up to what we're rotating by. And so anytime that happens, when there's no gap between the region and what it's being rotated by, your cross sections are going to be disks like this. Now their thickness is going to be dy. And their radius is going to be from here out to here. Now, since this is in terms of dy, what we have to do is we have to say, all right, get everything in terms of y. So this is good. This is x equals something. But I need to put this in terms of y. That is, I have to get x by itself. So if I get x by itself, I'm going to get x equals y squared. Now that's important because what's this length from here to here? Well, this is 4 and this is y squared. So if I want the length to find the radius, that's going to be 4 minus y squared. You always take the big minus the little. And so this is a larger quantity than that one. So the volume of this slice, it's a circle, so it's pi times r squared, so it's 4 minus y squared, times the thickness, which is dy. And so I want to add up all of these slices. Now remember, it's dy, so we're adding them up in this direction because this is how they're stacked. They're stacked up and down. So go from 0 to 2. I'll put the pi out front. 4 minus y squared dy. And there is our integral. And again, in this video, we're not going to go about calculating the integral. Just finding the integral is enough. You can look at the other video integrals like that. Number 2. Here we have the region bounded by 4 minus x squared, y equals 0, and x equals 0. So here is y equals 4 minus x squared. Y equals 0 is down here, and x equals 0 is right there. So this is our region. And it's rotated about the y-axis. So we're rotating this way. So when we take this region, it's going to look like that. So our thickness is dy, and our radius is from wherever we're rotating out to the edge. Now I need to put this in terms of y, and right now it's not. So what I have to do is I have to subtract 4, take over the negative, 4 minus y equals. So now it's in terms of y. How do I know? Because x, the other variable, is by itself. So the radius is this minus that. So it's square root of 4 minus y minus 0. So that is my radius. Square root of 4 minus y. So the volume of this slice is pi times the radius, square root of 4 minus y squared dy. Now I'm adding up all these slices up and down this way. So it's starting when y is 0 and going till it's up here when y is 4. So we have pi, 0, 4. Now here the square and the square root cancel out, so we have 4 minus y dy. There is our integral. On this last one, first we want to find the region. It's bounded by these 3. So we have y equals x squared, y equals 4. This happens at 2, 4, and x equals 0. And it's rotated about the y-axis. So we're talking about this region rotated this way. So our circles, our discs, are going to look like that, stacked this way. Now their thickness is dy, and their radius goes from the center out to here. Now I need to put this in terms of y, so I need to get x by itself. So x equals square root of y. So out here this is square root of y, and out here this is 0. So square root of y minus 0 is square root of y. So the volume of this slice is pi times r, which is square root of y, squared dy. And so I'm going to add up all these slices from y equals 0 to y equals 4. And the square root cancel out. So it's y dy. There is our integral. Thanks for watching.